All right, Mr. P helps with calculus. This is Unit 2, Day 2, which now we're going to be talking about how to write an equation of a tangent line or a normal line using the definition of a derivative. And we're going to be using the most common format for definition of a derivative. Limit definition of a derivative. This happens to be f of x plus h minus f of x over h. Now, yes, I am using a different letter in this case, but it really doesn't matter. If this says f prime of z, and then you do f of z plus h minus f of z over h, that would be the same thing. It really doesn't matter what the letter is. This is the most common format for a limit definition of a derivative, and I'm going to try my best to explain to you why it is basically just the slope formula. It's really just y sub 2, or change of y over change of x, the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if we consider this happens to be this dotted line, a secant line going through this curve right here. Now, it doesn't really matter what the function is. We're really just using two random points on that function. This point right here has an x of, well, let's just call it x. And then this point right here has its x plus delta x, which means the change of x. So delta x is just how much the x has changed. So this point here would be x, which is this distance right of the origin, plus delta x. That's just x plus delta x. And then the height, well, this would be f of x. That would be the height of x. And this would be the height of x plus delta x, or f of x plus delta x. Okay, so what you would do is you would do the slope formula. You would take this minus this. So f of x plus f of delta x minus f of x would just give you this. And then this over this, well, x plus delta x minus x just gives you delta x. So when you subtract this minus this, you get the denominator. When you subtract this minus this, you get the numerator. And that's essentially just the slope formula. That's change of y over change of x. Now, we don't know what any of these are, but they're unknowns, but we can still use them to find this formula. Now, why does it say we're trying to find the limit as delta x is changing from 0? We want delta x, that distance between the points on the secant line, we want that to go down to 0. We want to squeeze it down to 0 because that's how you find the derivative. You find the rate of change of a singular point. So in other words, we're trying to take delta x, we're squeezing it down to a distance of 0. And then we're going to find the limit at that value, which means we're going to find the value of that point, which just happens to be the derivative. All right, with that understanding, so let's take a look at what a question looks like. Now, once again, a tangent line, and normally I'm going to use point slope form. And the reason why I'm going to use point slope form because they're going to give us a point, and they're going to give us a slope. The point is your x and y, and then your slope, which is your derivative. F prime of 4 means the slope at 4. When x is 4, the slope happens to be negative 3. So that's really just your slope right there. And then this is going to be your given y, and this is going to be your given x. And then all you have to do is plug the numbers into your equation, and you're done. You could change this to y equals mx plus b format if you really want to, but I would strongly suggest not doing that because if you make any mistakes on the AP exam, they will be marked off. You don't want to do more work than is required. A normal line is the same as a tangent line. So if we have a curve and we say the tangent line at this x value is this, a normal line would just be perpendicular through the exact same point. So a normal line, you don't really do any more than that in this class other than just being able to write the equation of a normal line. So it's the same as the equation of a tangent line. The only difference is this negative 3 is going to change to the opposite reciprocal. And that's how you find perpendicular. We know that this line and this line have to be perpendicular if they have opposite reciprocal slopes. In other words, flip the slope over, that's the reciprocal, and change it to the opposite. Positive becomes negative, negative becomes positive. It just depends on what you have. All right, take a look at the next question. It says, write the equation of a tangent line. So we know it's a tangent line, no normal line here. We need a point and a slope. Well, they did tell us that x equals negative 2, so we got part of the point, but we don't have the y of the point, and we don't have the slope. So the first thing I'm going to do is find the y of the point. And the way I do that is pretty easy. I just take my x value, and I plug it in for all of the x's, which you can see I found f of negative 2 up here. and that's going to give me an answer of 1. So I now know the point is negative 2, 1. But I also need to know the slope, and the way to find the slope is to find the derivative at negative 2. So what I'm going to do is I'm going to use my f of x plus h minus f of x over h. Sorry, I'm going to use my limit definition of a derivative. Now, technically, this part right here is just f of negative 2 plus h. Now, if you don't know what that means, what it means is I'm going to take this, what's inside the parentheses, and I'm going to substitute it right here for all of the x values. So I'm going to put negative 2 plus h, that's your f of x plus h. I'm going to put negative 2 plus h here, and I'm going to put negative 2 plus h here. I kind of underlined the wrong spot. And that's essentially what you see right here. This is the f of x function. Instead of putting x in for x, I put x plus h in for x. All right, so we know the x value is negative 2, of course, because it gave us that. And then this is minus f of x, and I'm putting it over h. Now it's just a lot of algebra work, to be honest. I have to multiply this by itself. That turns into this right here. Negative 2 squared, h squared times by each other and double it. That gives you the middle term. I strongly suggest using that shortcut. Same thing here, distributed property gives you this, bring down the plus 1, and then over here, you can really just simplify this because it's all constants being multiplied or added to each other, brings it to negative, just 1, I guess. This is, so minus 1. Now what happens here once you get to this step is a lot of things are going to cancel out. These 4's cancel out, these 1's cancel out, and you're left with just this, which you can simplify down here. Then you can factor out, because both of the numerator terms can be divided by h. So I factored out the h. And then once it's a product, then I can cross it out on top and bottom. So I can reduce this down to just h minus 2. And once I've done that, effectively, once I've gotten rid of the h, now I can simplify by just plugging 0 in for h. So as h approaches 0, I'm not going to get an indeterminate solution anymore, because I've gotten rid of this h over h. You could not have put that. If you put 0 back in here for h, you're not going to get an answer because you're going to get 0 over 0. So yes, you do have to go through all these steps algebraically. 0 minus 2 is negative 2, and there we have it. We have found the limit definition of, we found the derivative at negative 2 happens to be negative 2. So I put negative 2 with the slope, and that's it, and I'm done. Now, this would be the same question. The only difference is this is a normal line. It's the exact same answer as the previous one, only instead of negative 2, it's positive 1/2 because that's the opposite reciprocal. All right, one more example, kind of the same thing. So we have a function f of x equals 1 over x, and we have x equals 2. So once again, starting from the beginning, we always need a point and a slope to be able to write the equation. We can't write the equation until we have a point and a slope to write it in point-slope form. Well, we have part of the point. We have x equals 2. First thing I need to do is put 2 in for x and find f of 2. F of 2 happens to be 1/2. Now we know this is our point. Last thing we need to do is find the slope. And we're going to find the slope because it's the derivative, or f prime of 2. And the way we use the derivative is we use the limit definition of a derivative. Once again, we're going to use f of x plus h minus f of x over h. And what we're going to do is take 2 plus h, plug it in right where the x is, as you can see here, and then basically minus f of x, so just plug 2 in for x, okay? And then over h. And then I can simplify, and we've had a previous video in Unit 1 of how to do that with complex fractions on top. Multiply both of them by the opposite denominator. Multiply this one by this denominator, multiply this fraction by this denominator. And what that does is it makes the denominators the same, and therefore you can subtract the numerators once done. And that's how I got here. Then I'm going to leave change, leave the top alone, change it to multiplication, change the bottom to the reciprocal. That's how I got here. Then I can reduce diagonally, and that's what we want. We're getting rid of that indeterminate right there, solution, because if we plug 0 in for h, we would have 0 over 0. So once we did that, now we're good to go. We can plug 0 in for h and solve. And we end up getting negative 1/4, and therefore this is your answer right here. We take our slope, put in our point slope format. Y minus the given y here. Well, technically it wasn't given. Technically we had to solve for it, but it is the given y equals m times x minus the given x, and that truly was given. All right, so every question might just give you a little bit different information. You never know what you're going to get. Sometimes they're just going to tell you the x value. Sometimes they'll actually give you the point. It just kind of depends on the question itself. All right, thanks again for watching. I'll see you on the next video, and I hope this helps.